So in this section, we're going to talk about the quadratic formula. And there's three things we want to be able to do because we want to be able to use the quadratic formula to solve equations. So we're going to look at three different types of equations. We're going to look at equations that have real solutions that are real nice, rational, everything works out and simplifies nicely. Then we're going to look at equations that have real solutions that are not so nice or rational. And then we're going to look at using the quadratic formula to find imaginary solutions, which is awesome. Okay, so here's the quadratic formula. The quadratic formula can be used to solve any quadratic that's in the form ax squared plus bx plus c equals 0. Now this is really important. First of all, your quadratic equation has to be set equal to 0. Then the other thing that has to happen is you have to determine your values of a, b, and c. So once you have those values, you're going to plug them into this formula down here, which is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's use that in an example. Okay, so here in example 1, we want to solve the equation x squared plus x minus 6 equals 0. So everything's good, everything's already set equal to 0. That's fantastic. And then looking at this, we can see that the coefficient of x squared is 1, so a is equal to 1. The coefficient of the x term is 1, so b is equal to 1. And then the constant that I have here, I'm subtracting 6, so c is equal to negative 6. And I rewrote the quadratic formula on this page just so we'd have it to reference. And so now we'll take all those values and we'll plug them in to the quadratic formula. So we'll get x is equal to negative b, so that would be negative 1, plus or minus the square root of b squared, so that would be 1 squared, minus 4ac, so that's 4 times a, which is 1, times c, which was negative 6. And all of that is over 2a, or 2 times 1. So now let's simplify it. First we're going to do inside the square root. So 1 squared is equal to 1, of course. And then we're subtracting from that 4 times 1 times negative 6. So 4 times 1 is 4. 4 times negative 6 is negative 24. So we're subtracting negative 24. And this is what is inside the square root. And then we were adding or subtracting that from negative 1. And we're dividing it by 2 times 1, which is, of course, just 2. So inside my parentheses, we have 1, or inside my square root, 1 minus negative 24 becomes 1 plus 24. So we'll have 25 inside the square root, but we were adding or subtracting that from negative 1, and all that was over 2. So the square root of negative 25 is 5. So that means we have 1 plus or minus 5 all over 2. Now this gives me two real solutions. This tells me that x is equal to negative 1 plus 5 over 2, or x is equal to negative 1 minus 5 over 2. So let's just simplify that. Negative 1 plus 5 is 4. 4 divided by 2 is 2. Over here, negative 1 minus 5 is negative 6. Negative 6 divided by 2 is negative 3. So in this case, we had two nice, rational, real solutions to the original equation. And in fact, this one, you would have been able to factor it. And if you'd factor it, you would have gotten x minus 2 times x plus 3. And if you set that equal to 0, you can see 2 and negative 3 are the solutions. So this one happened to factor. So maybe we wouldn't have used the quadratic formula to solve it, but we could have if we needed to. All right, let's do example 2, where the equation doesn't work out quite as nicely. So we have 2x squared plus 3x minus 1 is equal to 0. So that means that a is equal to 2, b is equal to 3, and c is equal to -1. Okay, so if we plug those values into the quadratic formula, we will get x is equal to, let's see, let me get a pen that works here. We'll get x is equal to -b, so that would be -3, plus or minus the square root of b squared, so that would be 3 squared, minus 4ac, so that's 4 times 2 times -1, all over 2a, so in this case that's 2 times 2. So let's simplify it. That'll be -3 plus or minus the square root of 9 minus -8. 4 times 2 is 8, 8 times -1 is -8, and all of that is over 4. So again, simplifying a little bit more, we'll get x is equal to -3 plus or minus 9 plus 8 is 17 all over 4. Now at this point, we want to check the number that's under the root, but here 17 is prime, so we really can't simplify it. So there's not really much else that we can do here. We can check to see if -3 is divisible by 4 and root 17 is divisible by 4, but they're not. So really, this is our not so nice, irrational answer. Oh, that's kind of cool. To the quadratic equation in example 2. All right, one more example, and that's what happens when we have imaginary roots. So let's solve the equation. Oops, I think this should say example 3. Sorry about that. X squared plus 2x plus 3 is equal to 0. Again, you could try to factor this, but you're not going to find any nice factors that work that help you solve the equation. But the coefficient of x squared is 1. And we can see that the coefficient of x is 2. And the constant. So let's go ahead and plug in those values, and we'll try to solve this. So we'll get x is equal to -b, so in this case that's -2, plus or minus the square root of b squared, so 2 squared minus 4ac, so that's 4 times 1 times 3, all over 2 times 1, 2a. So simplifying that, now we can see we have -2 plus or minus the square root of 4 minus 4 times 1 times 3, which is 12. And this is where our little issue is going to come into play, because 4 minus 12 is -8. And then we want to divide that by 2. So let's take a look at the square root of -8 here for a second on the side. The square root of -8 is equal to the square root of -1 times the square root of 8. And of course, the square root of -1 is I, and the square root of 8 can be simplified to 2 root 2. So I'll leave it to you to verify that that's true, that I didn't screw that up, but I'm pretty confident. Square root of 8 is really common. It comes up a lot, so I just remember that it's 2 root 2. So now we have x is equal to -2 plus or minus. Remember here we had the square root of -8. That's I times 2 root 2, so I'm going to write that as 2I root 2. And then all of this was divisible by 2. So now we can reduce that fraction. 2 goes into 2 once. So -2 divided by 2 is -1, plus or minus, and then 2 goes into 2 once again, so it would be I root 2. If we wanted to consider both solutions, we would say x is equal to -1 plus I root 2, and x is equal to -1 minus I root 2. I know the numbers are weird, but if I plug them back in for x into the original quadratic, it would make the equation 0. So that's it for our 3 examples. Make sure you get these in your notes, because you're going to practice some more with some complex numbers, and you're going to need to solve some equations using the quadratic formula for the activity that you're going to do next.